Hey guys, today we're going to be talking about a process called completing the square. We're going to be using perfect square trinomials to factor our polynomials into perfect squares. First, we'll recall solving quadratics with the square root property. Step 1, we need to isolate whatever is being raised to the second power. So in this case, that is the entire x plus 2. I'm going to isolate that on the left-hand side. So I add 2 and get x plus 2 all squared equals 49. Now from here I need to square root both sides to get rid of that exponent. Square rooting undoes squaring, so those two cancel each other. And on the right I must do the same thing, but always remember your plus or minus. So on the left I have x plus 2, and on the right I have positive or negative square root of 49, but the square root of 49 is 7. To continue solving I need to write two equations. The first, x plus 2 equals positive 7, and the second will be x plus 2 equals negative 7. The only thing that's changing is the sign on the 7. I have positive and negative 7. Now I can subtract 2 from both sides to get x equals 5, and I can subtract 2 from both sides in my second equation to get x equals negative 9. So my two solutions are 5 and negative 9. Go ahead and pause the video and try those next three on your own. For the first, you'll end up with a radical. Remember to simplify your radicals completely. For the second, you also end up with a radical. Again, I simplified completely. And last, we simplified to r is 10 and r is positive 6. On the next slide, we're going to complete each trinomial so that it is a perfect square. Remember the pattern here. In order to fill in this blank, all I'm going to do is take the coefficient of the middle term, in this first case it's 8, divide it in half, I get 4, and square that to add that to the end of my trinomial. So now if I were to factor this trinomial would factor into a perfect square. It actually would factor as x plus this number in parentheses, 4, all squared. To the right, I'm going to take that coefficient negative 14 and divide it in half. That gives me a negative 7. I then square that and put that number in my blank, so I add 49 to the end. To factor this, it factors as x and then minus 7 all squared. Down here below, I've got negative 16 when divided in half is negative 8. Squaring that negative 8, I'm going to add 64 to both sides. And then to factor, I take x and add a negative 8, or subtract 8, and square all of that. Last, dividing 12 in half, I get 6, and 6 squared gives me 36, so I add 36 to the end. And factoring, I have x plus positive 6, all squared. Note, this pattern will only work if your leading coefficient is a 1. So notice in all of these, my leading coefficient is always a 1. So this pattern won't necessarily apply directly if this is not a 1 in the front. So completing the square, the goal here is to rewrite the expression as a perfect square trinomial. Once we do so, we can factor it, and it will factor as something all squared. We can then solve this by applying the square root property as we did on the first slide. Step 1. Always move the constant term to the other side of the equation. The constant term is the term with no variable. It's whatever is just being added or subtracted to the end. Sometimes there is no constant term. In this first case, there is a constant term of 32. So I'm going to move this to the other side by adding 32 to both sides. Make sure you leave a space, because we're going to put a number here that we want instead of that 32. So I've got n squared plus 14n, and then I'm going to leave a blank here, equals positive 32. Step 2. Divide by a if necessary. So if a is not 1, which in this case my leading coefficient is 1, this is your a. Since it's 1, I don't need to do anything. If it is anything else, you must divide by that number. Step 3. Add the appropriate term to the equation on both sides to make the equation a perfect square trinomial. So I'm going to put a number in this blank so the left side is a perfect square. That number I find by dividing my middle coefficient by 2. That gives me a positive 7. And then I square that 7 to get positive 49. So I'm adding 49 to the space on the left-hand side. However, I have to add it to the other side of the equal sign as well. So I add 49 to the right. So my new polynomial is n squared plus 14n plus 49 equals 32 plus 49, which is 81. Now this left-hand side, this is a perfect square trinomial. When you factor, as we did on the previous slide, you will get n plus this number 7 all squared, and that equals 81. So now to solve, all we're going to do is square root both sides to get n plus 7 equals positive or negative square root of 81, which is 9. And then write our two equations and solve from there. I'll let you guys go ahead and do that on your own. I'm going to go ahead and go through the next couple. So again, step 1, move the constant term to the other side by subtracting. So I'm going to move my 35 over by subtracting. Step 2, I'm going to divide by a if necessary. So here I have a being 1, so I just have 1x squared plus 12x plus blank equals negative 35. Since my leading coefficient is 1, I don't need to do step 2. And step 3, I fill in the blank. So in the blank on this side, I'm dividing by 2 to get 6. And 6 squared is 36. So I add 36 to both sides of my equation. What I end up with on the left is x squared plus 12x plus 36. And on the right, negative 35 plus 36 is 1. On the left, when I factor this, I'm going to get x plus this number 6 all squared. You may use the diamond method as well if you'd prefer to do that. Square root both sides to get x plus 6 on the left equals positive or negative square root of 1, which is just 1. So writing my two equations, I have x plus 6 equals 1 and x plus 6 equals negative 1. I then solve each of these to find my solutions. Subtracting 6, I find x equals negative 5, and subtracting 6, I find x equals negative 7. So my two solutions are negative 5 and negative 7. Down below, step 1, I move the constant term by adding, so I add 24 to both sides. I then have 2n squared minus 4n, and I'm leaving a blank, equals 30. Then, step 2, I divide by a. Now notice here a is 2, so I do need to divide by a. And I divide everything by a, not just the first term. Dividing by a, my first term becomes n squared. My second term becomes a negative 2n. I still have that blank, and it equals 15. Now I fill in the blank with the appropriate number. Dividing my middle coefficient by 2, I end up with negative 1. And squaring that negative 1, I get positive 1, which I add to both sides of my equation. Now on the left, I can factor this. N squared minus 2n plus 1 equals 16. The shortcut to factoring would be n plus this number before I squared it, so negative 1 squared equals 16. And then from here you would proceed to solve. I'm not going to do that in this example. Last on this page, I add 21 to both sides to get 6n squared minus 12n with a blank equals positive 18. My leading coefficient here is a 6, so I must divide everything by 6 so that that leading coefficient is a 1 instead. So instead of 6n squared, I have just n squared. Instead of negative 12n, I have minus 2n. I still have a blank, and it equals positive 3. Now I fill in the blank. Dividing this middle coefficient by 2, I get negative 1, and squaring that negative 1, I add 1 to both sides of my equation. So my new polynomial is now n squared minus 2n plus 1 equals positive 4. We can factor this polynomial by taking n and adding this number before we squared it, so negative 1. Square that, and it equals 4. And again, you may proceed to solve. I'm not going to do this. I'll stop here. Please go ahead and take a moment to try this slide on your own after pausing the video. Remember that your steps are these 3, and you should have them already written down. Your first should have factored into p minus 7 squared equals 36. Second, you should have factored into n plus 3 squared equals 36. Third, b plus 1 all squared equals 9. And last, a plus 1 all squared equals 16. On the next slide, we're going to actually solve these all the way out. But here, I just wanted to practice the process of completing the square. So now, I'd like to actually go through and solve each of these completely. I'll do the first 2, and then I'll have you do the next 2 on your own. So I add 15 to both sides to get the blank that I need. N squared minus 2n blank equals positive 15. The number that goes in the blank is half of that middle coefficient, so negative 1 squared. That gives me a positive 1 that I add to both sides. So n squared minus 2n plus 1 equals 16. And on the left, we can take a shortcut to factoring. We take n, and we add or subtract the number that we had before we squared, so that would be minus 1, all squared equals 16. Now square root both sides to undo that exponent. Don't forget your positive negative. So n minus 1 equals positive or negative square root of 16, which is 4. Writing our 2 equations, we have one equation, n minus 1 equals positive 4, and the second, n minus 1 equals negative 4. Adding 1 to both sides, we find n will equal 5, or n will equal negative 3. So our 2 solutions here are 5 and negative 3. On the right, I add 47 on both sides. On the left, I have 4v squared minus 8v equals positive 40. Don't forget to leave a blank. We then divide by the leading coefficient of a. Here it's a 4, so we must get rid of it by dividing. That leaves me with just v squared minus 2v with a blank equals 10. To fill in that blank, I take my middle coefficient and divide by 2. I get a negative 1, and then square that to get a positive 1, which I add to both sides. So on the left, I have v squared minus 2v plus 1 equals positive 11. Factoring the left, I take v and I add a negative 1 because that was the number I had before I squared it. All of that is squared, and it equals positive 11. I square root both sides to get rid of that radical. Don't forget plus or minus on the right. So on the left, I have v minus 1, and that equals positive or negative square root 11. Since we can't simplify it, we leave it just as the radical of 11. And then we write our 2 equations. v minus 1 equals positive square root 11, and v minus 1 equals negative square root 11. Add 1 to both sides to get v equals positive square root of 11 plus 1. And on the right, adding 1 to both sides, I have negative square root of 11 plus 1. So your 2 solutions stay in terms of a radical. I have positive rad 11 plus 1 and negative rad 11 plus 1. Go ahead and finish this slide on your own after pausing the video. And then I'd like for you to proceed and do this last slide on your own as well. Thank you so much for watching. I hope you guys enjoy the rest of your day.